For the rest of the examples before we get to classical, I'm going to go a lot faster on just because we've already covered how to handle ands, nots, and ors, which means that you should be able to do a lot of these on your own, and I encourage you to do so. So those are going to be these. Let's see, it's like 7 examples. So let's just dive right in. So for the first one, we need an if and only if statement. We know how to handle that. That's going to be with, let's just use tactic mode for most of these. We're going to do a have. Do we want to use halves? Let's just skip that. We'll just directly create the constructor with 2 lambdas. We're going to have the modus ponens first, which is going to be h not p or q, and we need to show that that is if and only if, if that is true, then not p and not q. So h not p or q is a function that takes an or and gives us back false. And we need to show, let's look at our goal here. We need to show, I don't need to do tactic mode yet. Okay. Let's see. Let's just fill this right in. It's going to be an and h not p, h not q. Right, so we need to show not p and not q. So that's going to look like something like this. And then in the first case, we need to show not p. We know that's a function. It takes a p and returns something. We're going to have to apply our h not pq here to some variant of hp. And that's going to be injection, right? We don't have to do this by hand. We can just once again use exact to get through this faster. Although it looks like to give exact a little bit more help. Okay, change this to the left, and then we're set. In the second case, HNPQ, it's not helping us because we need a lambda of HQ first. Okay, great. Let's put these on new lines so they're readable. And we're done. Next, we need to do the modus ponens reverse, which shows a function that p or q implies false. So we're going to have hpq for p or q, and we need to show false from that. Now, because hpq is a function, once again, hpq is an or, we're going to recognize that we have the ingredients for or.elim, because HNP and HNQ are functions, and that will just close the goal right off. In the previous video, we had something similar for the and. We can actually use and instead. My intuition tells me that if we can do this for the or case and the modus ponens reverse, then we should be able to do something similar for and that would look like this. So we're building an and, which means that we're going to replace this with an and.intro. And and.intro takes an a and a b. These a's and b's are functions, but we notice our composition, right? So these functions are just the composition of HNPQ after or.inl. Okay, so that means that comp of these 2 functions is what we can give directly to our and. I'm going to skip the and.intro because it's implied from the angle braces. And it's going to be that and that. And for this case, great, very cute. So now we're done with that. Okay, moving on. Not P or not Q implies not P and Q. Okay, so let's do this in tactic mode. Don't forget that we have access to our intro. Do pattern matching on ORs. We have H not P and H not Q. After we do this, we get two cases. One, we need to prove not P and Q, and then the other, we need to prove not P and Q from not Q instead of not P. Okay, so now it's a little tricky. How do we show not P and Q just from not P? There's no such thing as injection into an and, because that's a logical fallacy. So, all right, let's think about this. We're missing, we know that if we want to show an and, well, if we want to show a not, it's a function. So we'll start by doing intro P and Q, because that's going to be the argument that this function will take. But we can pattern match directly. So our intro I like to put the R intro on the next line just so I know that it's not, that the error is not with the R intro. And well, now it's just easy, right? We just apply HNP to HP. We use exact. Okay, but we didn't need the HQ, so we'll just put an underscore here to show that more clearly. Clearly, we'll have some kind of symmetry using HQ instead of HNP and HNQ. All right, great. These could have been done with a lambda as well. Just directly pattern match in both cases and return HNQ on either left and right. But there's also a cute little function And.elim, which is exactly what we want here. In both cases, we can say a lambda from HP and Q, and then we're going to do HPQ dot, and this is a bit different syntax for saying And.elim. We're calling the method on the and object in object-oriented programming terms, but it's just different syntax for the exact same thing. There are no objects in functional programming, just classes and definitions, and not the classes from object-oriented programming. So HPQ, and then we can hit control space here, or at least we should be able to hit control space here to see what's available to us. Unfortunately, we're getting a little bit of an error, and that's because we're in tactic mode still. So we'll say exact. Now when we do control space after the dot, we see our elim is our first suggestion. And elim is, well, I thought it would work. Maybe we need, maybe it won't work. Let's see. We need a function. We need to give it a function from P to Q to false. Maybe I'm getting distracted trying to do this the hard way. Okay. Yeah, this is what I was looking for. HP, HQ, HNP. The same thing with the underscores. Parentheses are optional. We have to show not P and not P. This one doesn't seem to have on its surface any implications. It might be very weird to prove something like this without starting with anything. But this is not this is not a single term. This is still an implication. And it's a lambda that takes an and p and not p. And it shows from that not p and not p. Sorry, it shows false from that. Well, that's just what we already know is HNP applied to HP. Here we have the same thing, lambda p, this time not q. And we need to show a function of a function to false. So we'll show HPQ goes to, HPQ is our function, and it needs to go to false. Well, I know that we have a P, and I know that we have a not Q, which is a Q to false. So I need to apply HPQ to P to get the Q, and then I need to apply not Q to that to get the false. So now we're getting an application type mismatch. Let's, oh, forgot the H, okay. Okay. Now let's just check if we can do this a bit more acutely. I promised I wouldn't, but it's too tempting. HPQ of HP. I don't see an easy way to do it. No, I see it. We can do HPQ, H and Q after HPQ. HPQ, H and Q after HPQ. It's going to look something like some function composition applied to HP, where that function composition is only going to have one argument, right? And that argument's, no, okay. Let's think about it a bit more then. So, whoops. So this is applying H and Q after HPQ. So let's, first of all, let's do this one step at a time here. This is, of course, H and Q composed with HPQ. Now we can remove the lambda. Should have done this in the first place. We can remove the lambda by introducing the dot and getting rid of this. Oh no, that doesn't work because we're applying HP before we would be applying this lambda to HP directly, but we want to do that after we apply H and Q. So yeah, this no need to do point-free programming here. It would just make it a lot harder to read. Next one is not P implies Q. So with this one, we don't have a Q, which means immediately I know that we're going to have to use some kind of ex falso quad libet or whatever, which is just Latin for from false anything. So we're going to have lambda HNP, and we need to show a lambda P to Q. Of course, we can just get rid of the unnecessary lambda here, and we can apply H not P to HP to get false. Then we can use a built-in function called false.elim, which is what we want. Okay, but this can definitely easily be written in terms of function composition. It's just H and P after false. Sorry, false.elim after H and P. This is a good example of when we can get rid of an argument to an operator. And this is just false.elim. We have to put that in parentheses. Okay. Not P or Q implies P implies Q. We're going to have lambda not P or Q, and we need to show P implies Q from that. So that means we're going to have two arguments, not P, and P. No, we'll just call it H because otherwise the naming is going to be very long and confusing. And then HPQ. We need to show from this, we need to show Q. Well, now we need to do some pattern matching here. We're going to match H. We'll call it H or, so we know it's an or. And the first case is going to be when we have not P. And this is going to be or dot, I know, H not P. Just make sure that's right. That's right. Q in the right case. I have not P or Q. We have P and we have not P. Okay, in this case, it's easy, right? If you have, how did we get, that's why I was confused. Yeah, this is HP, not HP or Q. In this case, this is going to be false.elim, and I'll show a different way of writing false.elim. We're going to write HNP HP dot elim. So that's the same thing as we did up here, where we said HPQ was an and.elim, calling a method on and. This is equivalent to this, just with different syntax. And in this case, we need to show Q, but we have Q already. So this is just HQ. Okay, that was surprisingly easy. Just put this on a new line. We're done. Okay, P or false, only if P. This is going to be two functions. And P or false, both P or. That's going to have to go to P. In case we have P, that's going to have to go to P or false. That's easier, right? Because we already know how to do this. This is or dot injection is on the right. Also, to make this a bit easier to read, we can use the show keyword. So we can show P or false explicitly. Show P or false from or dot inner, because clearly you don't get to see what's being injected because Lean is inferring it. This is a way of making it explicit. Pattern match on HP or. Whoops. Let's see commas. I was wondering why everything was going too well. Yeah, this is, of course I got it wrong. This is injection left. It's always wrong. Okay, HP or. We could pattern match and handle either case, but we actually have or.elim ready with very basic functions. Or.elim needs to show from an or that we have an A to C and a B to C. And in the P to, in the first case, it would be a P to P, right? And that's just ID. And in the second case, it's false.elim, right? So if we just give those directly to the elimination function for or, it can handle this just fine. All right, great. One's left, and that's P and false, if only if false. Just going to same strategy. And I know I said I would do these in tactic mode, but it's just so much easier in functional mode for these simple ones, where you're just really making a few constructors. So this is just pattern matching P and false. Let's call it HF. And we need to show from that false. In the second case, we are given false. And we need to show, it doesn't matter what we need to show. If we have false, we can just use false.elim, right? In the first case, this is just another way of saying And.elim ID, I believe. Sorry, which one was it? It was right, okay. And.in right ID. Or not. Darn it, I thought that would work. Okay, And.left says that given an A and C, we can show B and C. Okay, this is not eliminating anything. We need an eliminator, and the eliminator will be That'd be a bit weird. And let's go back to the definition. So we're taking an and. We take the right. First thing we do is we take the right side, and then we just give back that right side. That's all we do. I don't know why I was thinking of stuff so complicated. This is just about right. Pretty funny. Sometimes you really overthink things. All right, great.